Hi guys, I'm Ajit Nair. I'm a master's student at University of Illinois at Chicago. I'm making this video as a part of an assignment of my cloud computing course under Professor Dr. Mark Greshnik. So the assignment is about performing map reduce operations on DBLP dataset. DBLP dataset comprises of different IEEE publications at different venues. The platform uses Apache Hadoop and the languages use Scala and Java. So the map reduce operation that will be performing calculating authorship score of authors, finding mean, median, and maximum of the number of co-authors across different articles and publications for an individual author, finding the number of authors in papers and assigning them to different bins based on the range of authors, and finally finding the number of unique collaborations of every authors in the DBLP dataset. So to start with, we'll traverse to the root directory of the project in Windows PowerShell. So I'm already at the root directory of the project. So the first step that we'll be performing is we'll clean compile the project and run the test cases. To do so, we'll run the command sbt clean compile test. So when we run these commands, SBT cleans your project. It removes any previously compiled assemblies and jars, and it recompiles it and then run the test cases. Uh, Meanwhile, I'll give you a walkthrough through the code. So I have a configuration file setup which includes different start and end tags of the XML for different type of application. I have given the output path. So these paths are basically the directories at which the output of the reducers will be stored. I have a map reduce DBLP main class. In the main class, I have defined different jobs to run the different map reduce operations. In the mappers class, I have specified different types of mappers, and in the reducers class, I have mentioned different types. I have basically defined different type of reducers. So let's go back to the terminal. Yeah, so we can see the code has been compiled and all the test cases have run successfully. So the next step would be to create the jar file of the project. So to do so, we'll execute the command spt clean compile assembly. By running this command, basically SBT would again clean your project, compile it, and generate a fat jar file, which would include all your dependencies of the project and the classes that you have written. When you execute the assembly command, the test cases are run again, and it basically checks whether all the test cases passes, and if there is an error, the assembly or the jar file is not created. The jar file is generated under the directory target. Target can be found at the root directory of the project. So under target, the specific there will be a folder by the name of the Scala version that you're using. Within it, the jar file is generated. Yeah, so we can see in the terminal, we can see that the test cases have passed, and yeah, the jar file has been generated. So like I mentioned earlier, the jar file could be found at the within the target folder within the Scala 2.12, and here we have the jar file. So the next step would be to upload a jar file to the AWS S3 storage. So in order to do that, I'll go to my AWS console. So yeah, in the Amazon Web Services console, we have different services, of which we will be using S3 to store our input file, jar file, and S3 is used for the storage of files, and we will be using EMR, Elastic Map Reduce, to perform our map reduce operation. So first, I would open the S3 management console. So I have a bucket here already. So to to complete the map reduce operation, you'll have to first create a bucket for your project, and within the bucket, you'll basically create a folder to put your input file. So I already have my input file within the folder DBLP input. Our input file is an XML file, dblp.xml. It's of the size 2.5 GB, and we'll be performing map reduce operations on this file. So I have my input ready. The next step would be to create a cluster on AWS EMR. So in order to do that, I'll go to EMR. You can see I have multiple clusters executed already. I'll create another cluster. So I'll click on create cluster, and then we go to advanced options. From the list of releases, we uncheck everything else except Hadoop. In the add step stage, we select the step type. We select custom jar, since we'll be executing the jar that we have created. We'll click on configure, and then we need to specify the jar location. So it would be yeah. So that was jar file that was already existing in the S3 storage. We need to upload the jar file that we have created now. So I'll go back to S3 storage. I'll go to my bucket, and I'll remove the existing jar file. Okay, and I'll upload the jar file that we have generated now. So I'll click on upload, add files. I'll select the path of my jar file. Select the jar file. Yeah, I'll click on next. Next, select standard. So my files will have the permission of the bucket that I've created. I have a DBLP output folder here. It has output of few of the map reduce operations that I've executed earlier for different clusters. I have a terrible upload speed. It's taking a lot. Yeah, so jar file has been uploaded successfully. Yeah, we can say it here. So we have a input file setup and we have uploaded a jar file as well. So now we'll move to the Amazon EMR service. So here I'll be creating my cluster. I'll click on create cluster. I'll go to advanced options. Here I'll select the release. I'll uncheck everything else except Hadoop, and in the step type I'll select custom jar and I'll click on configure. Here we need to select the jar file from S3 storage. So I'll click on my bucket name and I'll select the jar file that we have uploaded. And here we need to specify the arguments for the program. So in our program, we'll be giving the input and the output path, basically the directory of the input file, and we'll specify the output directory as well, where we need the output of the program. So my input file is in the directory DBLP input and space. I will give the output file directory is created by the EMR itself. So we need not create the output file directory. We just specify the name of the output file directory in the argument. So I'll give map reduce output. Okay, and this is very important. We need to select the action on failure. We'll select terminate cluster, or else on failure, it will basically keep on continuing the execution of the cluster. And I'll click on add. Okay. Next. So on this page, we can select the hardware configuration for a cluster. We'll go with the basic configuration, and I'll click on next. This page includes general options regarding the map reduce operation. I'll rename my cluster. I'll rename it as map reduce DBLP. Okay, and here we can mention the log folder in which the log should be generated. I'll keep it as default, and I'll click on next. We can specify security option. I'll click on create cluster. So the cluster has been created. So once a cluster is created, it will initially set up the hardware requirements for the operation. In the summary page, we can see the details of a map reduce operation. We have the log URI, and we can click on the steps function, and we can see the activity, the ongoing activity. If I click on view logs, no logs have been created yet. Once the map reduce operation commences, we can see the path, see the logs using this option. Clicking on the monitoring tab, we can see details regarding the ongoing activity. So it's still in the starting stage. Once the map reduce operation starts running, the status changes to running. If I click on application history, there's nothing here yet. I can click on the refresh button. Yeah. No logs have been created yet. In the events, we can see, yeah, the cluster was requested and is being created. Okay. We have the hardware configurations here. So I have uploaded the Java file and the input file using the GUI. Alternatively, you can if your input file size is of a size greater than 160 GB, you have multiple other options to upload your file. You can use AWS CLI, or you have AWS SDK, which you can use with Visual Studio to upload your file. Yeah, so it takes a while to have the cluster created and have it up running. So yeah, so we can see the status has changed. It's running now. So we can check the logs as well. We'll have to wait for a while for the logs to get generated. Once the map reduce operations are completed, we get details of the like we can go through the history and of the map reduce operation. We'll have a list of jobs that has been executed under the application history tab, and we can go through the logs as well. uh, okay, so it takes a while to generate the logs. Typically it takes about 19 to 20 minutes with the basic configuration that we selected. So I'll just fast forward this video to the point where the logs have been generated and the map. So a map reduce operation has completed. We can check the application history tab, and we can see that the operation has been completed and the status is succeeded. Like I mentioned earlier, under steps we can check the logs for the operation. So when I click on syslog, it will give me the log of the entire operation. We can see the progress of the map and reduce operations respectively. And yeah, that's everything about the map reduce operation. And back to the EMR console. So if we check application history, we can see our job diagnostic succeeded. Now if we go to our S3 management console, if we go to our storage, we can see there's a new folder that has been created by the name map reduce output, the one that we had mentioned. If I go inside the folder, I have a folder for my respective map reduce job. When I click on it, I have 3 files which has output of the reduce operation. So what I'll do is I'll download these files. Individually. Now I have my output in 3 files. So what I'll basically do is I'll combine their results through to a single file. So I'll get it from there and I'll paste them to a new folder. I'll open up a new PowerShell terminal and I'll traverse to the folder where the output files have been placed. Yeah, okay, there they are. So the first thing that I would be doing is I'll rename those files. So I'll rename them to file 1, file 2 and file 3. Since in a map reduce job configuration, uh, yeah, I've specified the text output format and I've mentioned the delimiter. So by default, it's a tab or space. Since I mentioned it as comma, my output file will be will contain comma separated values and it will be a CSV file. So yeah, I'll rename these files. I'll rename the first file as file1.csv. The second one as file2.csv and the okay, so I made an error there. Yeah, so the second file is file 3 and the third one is file 2. It doesn't matter, we just need to combine these files. So I've renamed them. The next thing I would do is I'll concatenate them to a single output file. So I'll run the command get content, and yeah, so when I do ls, I have a new file created, output.csv. We can open this file in Excel. Yeah, so it basically has a comma separated values in it. So this is one of the jobs for the for our convenience, for the sake of understanding the operation. I just taken one job. In our code, we have multiple jobs. I just commented the code for these jobs, and so I calculate the authorship score. I find the bin they belong to, that which you have already seen. I found the number of unique collaborations of each author with like the count of the authors with whom the every author has collaborated with, and the count of different types of publication, and another job to find the mean, median, and max of the count of co-authors in a paper for every author. uh, yeah, so that's a map reduce operation. We have implemented it on AWS EMR. I'll be adding a link to the GitHub repository of the project in the description. Thank you guys for watching.